Hi everyone, myself K.Nouseen Taj. I am from CSMB section, SRIT College. Today we are going to dive into one of the most powerful yet often misunderstood concepts in the C programming language, that is pointers. And over the next few minutes, we will explore how pointers unlock essential capabilities in memory management. Here is a quick look at what we'll cover today. We'll start with the basics as what are pointers, advantages of pointers, declaration and initialization, pointer operators, pointer arithmetic, pointers and arrays, pointers and functions, pointers to pointers, null and void pointers, dynamic memory allocation, common pitfalls, and best practices. Our goal is to make this complex topic clear and manageable. Firstly, what are pointers? At its core, a pointer is simply a variable, but unlike a normal integer variable that might store the number 10, a pointer stores a memory address. Think of your computer's RAM as a massive grid of mailboxes. A normal variable is like a mailbox with a specific letter inside. A pointer, however, is a piece of paper that simply says, go to mailbox number 7000 to find the letters. Pointers point to the location of actual data in memory. Crucially, a pointer must always be declared to point to a specific type of data, an integer. Pointers points to an integer, a character pointer points to a character, and so on. Next, advantages of using pointers. Why bother with this extra layer of indirection? Pointers are the workhorses of the C language. First is efficient memory access. They are essentially for dynamically allocating memory during a program's runtime. Second is performance. Direct memory access can make programs faster. Third is call by reference. They allow functions to change the original value of variables, which is impossible with standard pass by value. Complex data structures. If you have heard of linked list of or trees, pointers are the glue that holds them together. They are fundamental to advanced C programming. It can reduce code length and sometimes increases its speed. Used to build complex data structures like linked lists, trees, and graphs. Next, to understand pointers, we need to understand how memory works. Every byte of RAM has a unique address, usually represented in hexadecimal format, like 0x7000. When we create a variable, the system reserves space for it at one of these addresses. The key operator we use here is the address of operator, which is the ampersand symbol. If we have a variable called num, writing ampersand num in our code gives us the exact address where num is stored in the memory. Here, score might be at address 0x7FFE53D07A00 and PTR score holds this. And now next, we will see declaring and initializing pointers. Declaring a pointer requires a specific syntax. We use the data type it will point to, followed by an asterisk and the pointer name. The syntax is data type, asterisk, and pointer name. The asterisk indicates that the variable is a pointer. The data type specifies the type of the variable the pointer will point to, like example, integer, character, float. And to initialize it, we assign it a real address using that ampersand operator we just discussed. Integer asterisk ptr is equal to ampersand num means the pointer ptr now holds the address of the variable num. Next is pointer operators, address of ampersand and reference. The address of operator, this finds where variable lives in memory. The dereference operator asterisk, this is the inverse operation. When used with a pointer variable, it means go to the address stored in this pointer and give me the actual value that is sitting here. This action is often called gereferencing the pointer. Next, basic pointer example. Let's look at a simple example in code. We declare num as 20. We declare an integer pointer ptr and store the address of num in it. The address of num is same as the value of ptr. The value of num is the same as the value we get with gereference ptr. The most important line is ampersand ptr is equals to 50. We are using a pointer to reach across memory and change the original num without directly naming it in that line. Now, we will see the output of this code. This is how the output looks. Address of variable, address stored in PTR, value of variable, value accessed via PTR, new value of variable. Now we will see pointer arithmetic. We can perform basic arithmetic on pointers. If we increment a pointer, we don't just add one byte to the address. To the compiler is smart. It adds the size of the data type the pointer is pointing to. If PTR is an integer pointer, usually 2 bytes. PTR plus incrementation jumps forward by 2 bytes. This behavior is essential for efficiently stepping through consecutive memory locations, which is how we handle arrays. Next is pointers and arrays. Arrays and pointers are inextricably linked in C. In fact, an array's name is a constant pointer to its first element. Array name holds the same value as ampersand array name. Because of this, we can access array elements using pointer syntax. Array of I is identical in function to asterisk array plus I. Understanding this relationship allows for much more flexible and efficient array traverse. Now next, we will see pointers in functions that is called by reference. This is a key use case. In C, arguments are normally passed by value, meaning functions work on copies. If we want a function to permanently swap two variables, for example, we must pass the addresses of those variables to the function definition to accept those addresses, allowing the function to reach out and modify the original data. This is known as call by reference. Now next, pointer to pointer, that is double pointer. C allows us to store the address of one pointer inside another pointer. This is a pointer to a pointer, or simply known as double pointer, declared with two asterisks, that is int asterisk asterisk pptr. It adds another level of indirection. You have to dereference it twice to get back to the original value of the integer num. These are used in advanced scenarios such as when a function needs to modify an actual pointer variable past it. Now next we'll go for special pointers. Here we will see first is null pointer. It is a pointer assigned to value of 0 or null to indicate it points to the nothing. This is a good practice to prevent unpredictable behavior. While pointers. Next is void pointer. A generic pointer void that can point to any data type. It cannot be dereferenced directly without typecasting. Second is dangling pointer. A pointer that points to a memory location that has been freed or deleted. Accessing it can cause a program crashes, segmentation fails. Next is dynamic memory allocation with pointers. Pointers enable allocating memory at runtime on the heap rather than compile time. Key functions in standard library header file are malloc. Malloc allocates a block of memory of a specified size. Calloc allocates memory and initializes all bits to 0. Realloc resizes a previously allocated memory block. Free deallocates the dynamically allocated memory to prevent memory. Next, we'll come for summary. To wrap up the main points, pointers give you control over memory. Use the ampersand and asterisk operators correctly. Follow these best practices. Always initialize your pointers to null or a valid address immediately. Be very careful with pointer arithmetics to avoid accessing memory you should not. And always ensure that the memory a pointer points to is still valid. Avoid dangling pointers. Thank you.